We're practically swimming in a sea of data these days. It's everywhere. Every headline, every argument, every big decision we make. But how do you know if it's a life raft helping you find the truth or an anchor of misinformation dragging you down? Well, today we're building your statistical self-defense kit so you can finally tell the difference. Let's get you armed and ready. I love this quote from Andrew Lang. It just perfectly nails the problem, doesn't it? So often, numbers aren't really used to shed light on something. Nope, they're just used to prop up a shaky argument, kind of like a lamppost. But that's exactly why we're here. Think of us as your guide to finding the real light switch. Okay, first tool in our kit. We're going to tackle one of the absolute slipperiest words in the entire data universe, average. It sounds so simple, so harmless. But that's the trick, right? Its simplicity is exactly what makes it so easy to misuse. So picture this. You see a headline that says something like, the average fast food worker in the United States makes between $14,000 and $18,000 a year. Sounds pretty official, right? But hang on. There's a huge red flag waving right there. A real average is one number, not a range. So what's really going on here? Well, here's the secret. The word average is a bit of a shapeshifter. It can mean three totally different things. First, you've got the mean. You probably remember this one from school. Add everything up, divide by how many there are. Then there's the median, which is literally just the number in the dead center of a list. And finally, the mode, which is simply the most popular value, the one that shows up the most often. The key takeaway? From now on, whenever you hear the word average, your first question has to be, which one? And trust me, asking that one little question makes a world of difference. Let me paint a picture for you. Imagine a small company. 9 of the employees make a perfectly respectable $55,000 a year. But the CEO, she makes over $700,000. Now, if someone uses the mean to calculate the average salary, it comes out to a whopping $120,000. That number is technically correct, but it gives a totally warped view of what it's like to work there, right? The median, though, that's $55,000. That's the real story for the typical employee. See how just one big number, an outlier, can throw the whole thing way out of whack? All right, let's grab tool number 2 from our kit. And I'm not kidding. This might be the single most important idea you need to understand to make sense of the world today. This is the golden rule for not getting fooled by data. Okay, check this out. It's a classic example. For decades, data has shown that when ice cream sales go up, burglary rates also go up. They move in sync, almost perfectly. So, what's the deal? Does eating a pint of ice cream suddenly make you want to go break into a house? Yeah, I'm going to say probably not. So what is really happening here? And the answer, folks, is the number one rule of data analysis. Correlation does not equal causation. Just because two things are happening at the same time or following the same pattern does not ever mean that one is causing the other. You see, to actually prove that one thing causes another, you have to pass a strict 3-part test. First, the cause has to happen before the effect. Makes sense. Second, there has to be a logical, testable reason why they'd be connected. But here's the big one, the one that trips everyone up, number 3. You have to prove there isn't some hidden third variable that's actually causing both. And in our ice cream mystery, that's exactly what's going on. The third variable is summer heat. Hot weather makes people buy more ice cream, and it leads to more burglaries because people leave windows open and go on vacation. Mystery solved. Okay, time for our third tool. This one is all about getting a new superpower, the ability to read the fine print. Because when you see a poll in the news with a big, bold number, that number is almost never the whole story. You got to understand the uncertainty that's hiding in plain sight. So a poll flashes across your TV. 41% of people support candidate X. It looks so precise, so definite. But that single number, well, it's kind of like a mirage. The real truth is always a little fuzzier than that. See, since polls can't ask every single person, they always have what's called a margin of error. So if that poll has a margin of error of, say, plus or minus 3%, it means the real number isn't a perfect 41%. It's actually somewhere in a range between 38% and 44%. And that range is the actual result. I mean, think about it. That could be the difference between a candidate having a solid lead or actually being behind in the race. And that leads to this kind of nerdy-sounding term, statistical significance. It seems complicated, but it's really just answering one simple question. What are the odds that this result is real and not just a random fluke? So when a study says its findings are statistically significant, it's basically them saying, hey, we're pretty darn sure this is a real effect and didn't just happen by accident. It's their stamp of confidence. Whew, okay, we've gone through some pretty tricky ideas. So now it's time to put it all together. Let's officially pack up your new statistical self-defense toolkit. So from this day forward, here are the 3 critical things you're going to do. Tool number 1, when you hear the word average, you're going to immediately ask, is that the mean, median, or mode? You're going to challenge it. Tool 2, when you see 2 things that seem connected, you're going to chant the mantra, correlation is not causation, and start hunting for that sneaky third variable. And tool number 3, when you see a poll, you're going to ignore the headline number, find that margin of error, and see what the real range is.
With this toolkit, you're not just a passive consumer of data anymore. You're an active detective. So the next time a statistic screams at you from a headline, you'll be ready. You'll know the real question isn't just what the number is, but why they chose to show it to you, and more importantly, what they might be hoping you won't notice. Now go on, get out there and be a data detective.